Imagine that you're building an internal developer platform. What would be a good user experience if, for example, one would like to deploy and manage a backend application without spending 5 years trying to understand all the details about Kubernetes? How about Vela up and passing only a few lines of YAML containing only the information that actually matters without dealing with low-level details? That's it. That's all there is to do. Now, let's see what happened behind the scenes. We got a deployment which created a replica set, which created a pod that runs the actual application. We also got the service in charge of internal networking, a horizontal pod autoscaler that scales replicas of the app, and an ingress that is in charge of redirecting external traffic into the app. That application was deployed into the dev environment. Now, let's say that we would like to promote it to production. All we would have to do is to resume the workflow. Now, let's see what happened by listing all the resources, but this time in the prod namespace. There are always some differences between development and production, so we got a similar, yet not the same set of resources. For example, this time there are 2 pods since we need high availability, the ingress host is different as well, and so on and so forth. More importantly, the app in production needs a database which we did not yet create. As a result, the pods are failing since they are trying to mount a secret with database authentication. That secret does not yet exist. Let's fix that by deploying a database server and everything it might need by executing Vela up, passing it the manifest that is only a few lines of YAML, and making sure that we are doing it in the prod environment. That's it. That's all it took to deploy a backend application to both dev and prod, as well as to get a database running in a hyperscaler of choice, whichever you want. And here's the question though. How did I do all that? And why did I do it the way I did? Let's take a quick break to introduce you to Twingate, the sponsor of this video. Let me ask you something. Are you tired of using VPNs, but you still want to work securely? If you are, this might be the time to ditch, remove, get rid of VPNs. I mean, they're evil, right? And to switch to Twingate. It is a VPN replacement. Now, when I say VPN replacement, I don't mean the kind of VPN that allows you to watch Netflix or the kind of VPN that allows you to access your bank account. I mean the kind of VPN that allows you to access your network, your infrastructure, devices, home lab, or anything else related to your work. And the best part is that it is not a VPN. It is not one of those that end up preventing you from working or making your internet connection feel like you're using a modem from 90s. It's easy to set up and it's fast, like really fast. There is a free tier, try it out, get rid of VPNs. Thank you Twingate for sponsoring this video, and now let's go back to the main subject. Let me start with the question. What do zombies, Jesus, and open application model have in common? They were all resurrected from dead. OAM, which is short for Open Application Model, is an attempt to standardize application definitions. It is a spec that was born in Microsoft only to be abandoned shortly afterward. Microsoft made it, thought that it is a dead end, and then it killed it. However, OAM did not stay dead for long. Then came Alibaba, resurrected it from the dead, mainly through the KubeVela project. Open Application Model is a spec, and KubeVela is the implementation of that spec. Now, back in the day, I thought that KubeVela was one of the most interesting and most useful projects, especially for those building internal developer platforms. Since then, I switched to other projects that perform similar functions and eventually settled down on crossplay. Nevertheless, KubeVela kept evolving and added a lot of very interesting features and capabilities. So I went back to it in an attempt to figure out whether I made the wrong call. I wanted to see whether it overcame the issues that compelled me to abandon it, whether I should come back to it, and whether its new ideas might be worth adding to other similar projects. So today's video is a walkthrough through KubeVela. We'll see what it does, what's old and what's new, whether you should adopt it, or if you're already using it, whether you should continue investing into it. By the end of this video, you will be equipped with knowledge that will help you make a decision whether to use KubeVela as one of the building blocks of your internal developer platform. To start working with KubeVela, we need to initialize an environment. So let's just do that with dev and prod. Those environments are essentially namespaces in Kubernetes. Now, let's confirm that by listing all those in the cluster. We can see the dev and prod are there. There is nothing really special about them, apart from a label Vela put into them. We could have created them without the CLI. Now, the core of KubeVela are components that define all the base resources it will compose for us. Here's an example. The first thing you will notice is, for some reason, a strange syntax. Everything we define with KubeVela is written in Q, which is a language built on top of Go, aiming to make it easier to write complex configurations. It is a data-driven language that is both a superset of JSON and Go. Over there we have app backend, which acts as a name of a component. The main resource it will manage is a deployment. Further down we have a template that defines all the parameters and the resources it will manage for us. Think of it as Helm template that will be running in Kubernetes instead of your laptop, and that will create new API endpoints in Kubernetes API. Or sort of. I don't know. We'll see. We'll get to that. Over there we have image, tag, port, host, ingress class name, and DB parameters, with DB having two subparameters, secret and secret namespace. Those will be parameters others will be defining when they use that component. Think of those as Helm values file, except that it will be available in Kubernetes API, or kind of. Again, we'll get to that. The output section contains the list of resources it will assemble for us. There is a deployment, a service, and an ingress. If you ignore the fact that it is written in Q, those would be the same definitions you would normally write as YAML files. The major difference is that some of those values are templates. Some of those are using built-in values like context name, while others are using parameters defined earlier. That would be, for example, parameter image and parameter tag, which we're using to construct the image value for the deployment. All in all, if someone requests the app backend component, KubeVela will create a deployment, a service, and an ingress with the parameters we defined. So far, so good, right? It's easy. Now, let's apply that component, and by doing that, make it available to everyone else, with everyone else being users of the platform we are building. That's it. From now on, our users can create and manage backend applications without having to deal with deployments, services, and ingresses. We'll make it more complicated later, but for now, that's it. Okay, now that we created backend app as a service, let's see how can users know what to do with it. One option is to go to the KubeVela UI, which we'll explore later. Another option is to use the CLI to show the information about the component. We can see the specification with the same fields we defined in the component. Since DB has some subfields, they're listed separately. We can also list all the component definitions in the cluster. We can see that there are some predefined components available, as well as the app backend we just created. Finally, let's list Kubernetes CRDs related to OAM. As a side note, KubeVela is an implementation of the Open Application Model specification. Actually, I said that earlier. Anyways, that's why we filtered the CRDs with OAM. Now, here's the first, in my opinion, issue we're facing with KubeVela. It does not create new CRDs. Whatever we do is always implemented as applications core OAM dev. That makes discovery harder than it should be. I would have expected a new CRD called, let's say, app backend or something like that. If we would get that, we could discover the schema for that specific resource. We could tell Backstage or whichever UI we're using as a platform portal to fetch that schema and generate fields for that resource. We could do many other things, but we can't, since it is always it's a bad idea. Anyways, it is always application CRD, no matter what we do. And that's a pity. Nevertheless, happy thoughts. From now on, users will be able to manage their backend application using the component we created. But there's more. We might want to add additional traits to the component. Now, let's say that we would like to enable users to decide whether their application should scale horizontally. Since that would be an optional feature, we cannot add it to our component directly. If we would, scaling would be enabled all the time, making it mandatory. not optional. KubeVela has the concept of traits, which are a way to add optional features to a component. Here's an example. This time we are defining a scalar. Unlike the previous definition, this one is a trait. Traits are a way to optionally attach additional resources to a component. In this case, it defines parameters min and max, both with default values. Those who attach that trait will be able to specify the minimum and the maximum number of replicas, which will scale automatically between those two numbers. Easy. Further on, we have a horizontal pod autoscaler resource, which will be created when someone attaches that trait to a component. Still easy. Let's apply it. That's it, at least for now. We have a backend application that will compose a deployment, a service, and an ingress, and optionally have a horizontal pod autoscaler. Still easy. Now, let's see how it all works. Now we will see how developers can use KubeVela to create and manage their applications. To begin with, we'll set dev to be the current environment. From now on, we as developers will be using dev environment, and we can manage backend applications either from the web UI or using the CLI. If you open the KubeVela UI, we'll see the home page where nothing is happening, at least not yet. From there on, we can select to create new application that opens a new model split into two sections. First, there are common attributes like the name and the description that apply to all KubeVela applications. The important part in this scenario is to select the app backend component we applied earlier, and you can select it only if it appears, and if it doesn't appear, then we have a problem, but that's a separate issue that does not really matter. Anyways, select whatever you want, whichever component you want. If we proceed to the next step, we can fill in the fields that are specific to the component we selected. Those are exactly the same parameters as those we defined in the component earlier. And now you can probably guess what happens next, right? If you can't, well, tough luck, since we'll switch to the terminal. Looking at graphical user interfaces for too long hurts my eyes. It's not healthy. A second reason for moving away from the UI is that it does not allow us to specify everything we can define ourselves. So off we go into the darkness of my terminal. Here's an example of a YAML. Now, there's a lot to digest here, so let's break it down. To begin with, we are defining an application resource. As I already mentioned, we cannot create our own CRDs with KubeVela, and that's a pity. Instead, it's always an application resource. The spec is split into multiple sections. There are components, policies, and workflow. The last time I used KubeVela, probably a few years ago, there were only components. So this is very exciting for me, very exciting. Using components is straightforward. We specify the name, the type, properties, and traits. The name is probably self-explanatory, while the type is whatever we defined it to be when we created the component. Properties are essentially the parameters we defined in the component, which will be used to compose the resource. Traits are optional. In this case, we are specifying that we would like to add the scalar to the mix. Now, none of those things we explored so far are new. What comes next are capabilities that did not exist the last time I used KubeVela. So now comes the interesting, exciting part. KubeVela policies are not what you might expect. They're not policies that define what can and what cannot be done, like, for example, Kyverno policies. Instead, they're a way to, to modify application before it is deployed. The first policy is of type topology. It is used to specify the destination of the application, which in this case is namespace dev. The second policy is of type override, which can be used to modify properties of a component or a trait. In this case, we are saying that the host parameter should be dev silly demo, etc., etc., etc. Then we have yet another topology that will deploy the application to the prod namespace. The fourth one will reduce the min number of replicas of the scalar to 1. Finally, the last policy will override the DB secret property. In this particular case, those policies allow us to have variations between the resources that will be composed in different environments, given that dev and prod are similar, yet not identical. Similar, but not the same. Now, the important thing to note is that none of those policies do anything by themselves. Policies are applied through the workflow, which will explore next. That workflow has 3 steps. The first one will deploy the application to dev environment, but before it does that, it will modify the application by applying target dev, host dev, and scalar dev policies. Once it's done with the deployment to dev, it will suspend the workflow and wait for someone to resume it. Once the workflow is resumed, it will deploy to prod environment, but just as with dev, it will modify the application by applying target prod and db prod policies. As a result of that workflow, dev and prod will be different, and the manual approval will be required to promote the application from dev to prod. All good so far? Now, on the first look, the idea of having policies and workflows feels like a very, very, very useful addition to KubeVela. Yet, I think it is silly. I think that the implementation is just wrong. Something that was supposed to be easy for people to consume all of a sudden turned itself into something complicated. We'll talk about that later. For now, imagine that I did not say anything. Happy thoughts. Fill yourself with happy thoughts and let's move on. Now, let's apply that application definition and see what we'll get. Now, to be clear, we could have created that application from the web UI as well. Similarly, we can observe it in the UI as well, but we won't. We'll stick with the terminal. We can get all the applications in the dev namespace. The only thing I want you to draw your attention to is the phase column currently set to workflow suspending. If you remember the definition we explored earlier, it was to be expected for it to go into some kind of hibernation after composing the resources in the dev namespace. That's what we defined in the workflow. The interesting part is what that application composed. There's a deployment which created a replica set, which created the pod. We also got the service and an ingress. Those are all pieces of the component we are using. On top of that, since we chose to add the scalar trait, we got the horizontal pod autoscaler as well. We might also want to pay attention to the ingress host. It is set to dev.silly_demo because the workflow step that deployed the app to the dev environment applied one of the policies that changed the host. Now, to be 100% clear, so far we deployed some resources to the dev namespaces and we suspended the execution of the workflow. Nothing was deployed to production so far, at least. Capish? If you ever get confused what's going on and what happened so far, we can always ask for the current status. The workflow deployed to dev, and after that, it suspended the promotion. So for services, we are running app backend only in the dev namespace, at least for now. If you would like to see which resources were composed, we can output the status in the tree format. The KubeVela application composed a service, a deployment, a horizontal pod autoscaler, and an ingress. We knew all that already. Nevertheless, it is nice to know that we can list all the resources managed by a KubeVela application. Okay, so now that dev is up and running, we would normally run some tests, do some manual reviews, or anything else we might need to be doing. Now, it is unclear how would KubeVela trigger those processes. We might want to use HTTP do workflow step to trigger some other processes that would do whatever we need to be done. We might also execute apply workflow step to apply some other resources that would run tests or whatever we need to be done. I'm not sure about any of those. It is certainly doable to connect KubeVela workflows with other workflows, but that does not seem to be, thought through. I feel that the assumption is that KubeVela workflows themselves are sufficient, which is certainly, and I repeat, certainly not the case. They are not sufficient. Now, I will leave that as an exercise for you and assume that we validated the release in the dev environment and that we are ready to promote it to prod. So let's check the status again. And now we can see that this time we got the release not only in the dev namespace, but also in prod. And we can also confirm all that further by listing all the resources in the prod namespace. There we go. We promoted the application from dev to prod, and while doing that, we made slight changes to the resources through policies. All that being said, the pods are not running. Kubernetes complains that their status is create container config error. Those pods are trying to mount a secret that provided credentials to the database, and since we did not yet deploy the database, the secret does not exist. Let's fix that with a new component definition. By the way, the outputs you will see are based on databases in Google Cloud. If you prefer using AWS or Azure, you will find the instructions how to do the same over there in the manuscript, and the link is in the description. It's somewhere there, down there, or to the right, left, it's somewhere. Here's the definition of the database component. That component follows the same pattern as the previous one. The major difference is that this time we are not composing core Kubernetes resources. Instead, we are combining custom resources that will ultimately create a database instance in Google Cloud as the main resource, and the user and the secret as the other resources. We are using cross-plane managed resources for that, for two reasons. First of all, we are trying to manage a database in a hyperscaler like Google Cloud. We could have accomplished the same with other operators like Google Config Connector or AWS Controller for Kubernetes, BasicA, or Azure something something, or anything else. That brings me to the second reason. I wanted to prove that competing tools can be combined. We are using KubeVela in the similar capacity as cross-plane compositions, but since KubeVela does not have something similar to cross-plane managed resources, we are combining the two. Now, to be clear, KubeVela does support the usage of Terraform, but that is just silly. I have nothing against Terraform in general. I think it's great, and that it changed the industry in many ways. However, Terraform does not work well inside Kubernetes. Now, I will not go into details why I think so, because that would result in a complete derailment from the main subject. In any case, you're free to fight me on that one in the comments. Tell me how I'm wrong about running Terraform in Kubernetes. The resources we are composing are customizable through parameters, region, size, and version. Now, those should hopefully be self-explanatory. So let's just apply that component. From now on, whenever a developer or anyone else needs a database, they can create a KubeVela application that uses that component. We'll see that in action in a moment. But before we do that, since that component we just saw assumes that there is a secret with the root password to the database, we'll create that secret first. To be honest, that is not something anyone should do. Instead, we should have stored that password in a secret store and pulled it with something like external secrets operator. However, that would also derail us from the main subject, and at the same time I was too lazy to edit to this demo, so we did what should never be done and created a secret directly. Sue me. Now, a developer or anyone else can define the application that uses the component, and here's an example. That was easy, wasn't it? We defined an application that uses DB Google component with the region set to US East 1, the size set to small, and the version set to 13. That manifest contains all the information needed to create the resource and is at the right level of abstraction for a person that does not want to know everything required to run a database in a hyperscaler, right? So it's a abstraction at the level needed for people to do what would be otherwise hard to do if they don't know it in details, if they're not DB experts. Now that the user of the platform defined the application, all they have to do is to make it real is to apply it and check the status. That status is actually not useful since it does not show the status of all the composed resources nor the overall status of the application. Now, that can be fixed with health policy, but that would require a lot of work, especially on more complex steps. So it's possible, but not necessarily something many will do due to the increased complexity. Next, we should probably wait for a while until all the resources are operational in whichever hyperscaler we chose. And fast forward, and after a while, we can list them with the following command. We can see that all the resources are ready, so we can proceed. Let's get back to the first resource we applied, the one that composes backend application, and check whether the pods are now running. And there we go. We can see that the pods are now running. They were failing before because they were trying to mount a secret with database credentials which did not exist. Now that we applied the database as well, which in turn created that secret, the pods are running. Hooray! And that's about it. We got two KubeVela components that compose resources in different ways. One is managing databases in hyperscalers, while the other is managing backend applications in Kubernetes clusters with those apps being connected to those databases. Optionally, platform users can easily define what they want without the clutter of underlying low-level resources. So, here's a question. Does everything we saw so far make sense? Let's talk about it. It's very hard for me to put my finger on KubeVela. It's as if the direction of every important feature is the correct one. Yet, we somehow end up in the wrong place. I think that's just as valid for application spec as for policies, workflows, and integrations. Now, I will get back to those in a moment. For now, let's talk about pros and cons. Let's start with those that I don't like. Here's the first one. I don't understand why KubeVela insists on having a single CRD application. As it is now, there is no reliable schema. An application can have any number of components, which in turn can have any number of traits, and none of that is enforced at the Kubernetes API level, but rather through the KubeVela CLI and the KubeVela engine. As a result, other tools cannot easily deduce what is what, how to use it, what the schema is, and so on and so forth. KubeVela would improve greatly if it would adopt a model where we would be able to create new CRDs like backend app, DB, or anything else. Now, whether that would mean removal of the application model, the OAM, in favor of working directly with components or something else is beyond me. What matters is that it does not make sense to insist on predefined application CRDs when it's so easy to create new ones. As it is now, KubeVela does not provide discoverable schemas, and that is a pity. Next, policies and workflows are conceptually great. Other tools in that area would benefit greatly from having something similar to what KubeVela has. I do believe that Crossplane and CRO, and that's only to name a few, should add capabilities that serve that same objective or those objectives. That being said, both fail at the fundamental levels. The primary value of tools like KubeVela is the ability to create our own abstractions and simplify lives of those who will use such abstractions. KubeVela does that pretty well with application and components and traits. Yet, when it comes to policies and workflows, it chose to completely change the direction. All of a sudden, low-level details are not abstracted anymore, but move to the forefront. Now, that's not something necessarily bad. Some users like dealing with low-level details, while some don't. The problem is that KubeVela end users don't. If they do, they pick the wrong tool. It's all about one team, call it platform engineers, building components and traits while everyone else uses them. Then, all of a sudden, it all falls apart with policies and workflows. All of a sudden, rules are inverted. So those building services are mostly doing nothing, while those consuming them are dealing with low-level details. KubeVela should have done with policies and workflows the same as what they did with components and traits. They should move them to the server side and expose parts that matter to end users. What else? There is very poor integration between KubeVela and other tools from the ecosystem, which is probably why KubeVela is building its own, often as poor replacements for what we already have. Here's an example. With a single CRD application serving potentially infinite number of permutations, it is close to impossible to define server-side policies like those we typically do with Kyverno. There isn't much we can do on the admission control level if everything is the same resource and there is no schema. No schema. Kyverno will not work unless in very simple scenarios, but that's only one out of many. You'll have trouble using KubeVela with Argo CD. You will face challenges trying to observe applications through metrics from, let's say, Prometheus, and so on and so forth. Simply put, KubeVela ignores quite a few Kubernetes rules, making it very hard to combine it with the rest of the ecosystem that follows those same rules. That could be the biggest downside given that the ability for everything to work with everything else is one of the main advantages of Kubernetes. KubeVela tries to solve that, not by trying to make itself closer to what is expected from Kubernetes native apps, but by building its own ecosystem. That feels like a waste of time. Let's do one more. Only one more. I have others, but one more. KubeVela supports only Q. Now, to be clear, I think that Q is great. It is one of my favorite languages, at least when it comes to defining the state of something. Still, the fact is that Q is nowhere near as widely adopted as it should be. If Q is what you like, and everyone else in your organization agrees to that, great. But if that's not the case, KubeVela is a non-starter. There was a period when quite a few projects were formed around the idea that Q is going to dominate the world. Most of them failed, and as a result, either stopped existing, that's one option, or more often than not, recognized the need to support other languages. Q is great, but is also a niche language. And as long as that keeps being the case, it is not a good idea to make it the only choice. There are other issues which we won't dive into today. Those that I mentioned are, in my opinion, fundamental and not something that can be fixed with a bit of polish. Others are less important. Now, let's see what's good about it. To begin with, Vela CLI is fantastic. It is truly great. It, in a way, shows how necessity often produces something great. Given that KubeVela itself does not work well with the rest of the ecosystem, we cannot rely on other tools, those that we typically use, to help us with whatever we need to do. Typically, I would expect to be able to do everything with kube control, with any additional tool making it just more convenient. With KubeVela CLI, it is not about it being more convenient, but rather often being the only option. That's the necessity I mentioned earlier. As a result of that necessity, the team was forced to pay extra attention to the CLI, and I must say it's really great. Big thumbs up. WebUI is more or less great. That could be its biggest selling point, given that graphical user interfaces are the most common ways for end users to interact with services. Finally, there are policies and workflows. That might sound confusing since I put those into cons, so bear with me. I was very negative towards KubeVela implementation of policies and workflows, but I do give them a credit for having them. If there is anything other tools in that space should learn from KubeVela, those are two things. We need something like policies and workflows integrated into compositions in case of crossplane and resource groups in case of crawl. Second, we should not implement them in the same way as in KubeVela. That being said, for now, KubeVela gets a thumbs up for having policies and workflows baked in, even though they're not great. All in all, I do think that open application model is broken on a very, very fundamental level. KubeVela as a project is great, and in many ways, it is leading in certain area. Yet, the project itself is being dragged down by the issues in the open application model. I feel that KubeVela is trying to break away from it, but is unsure how to do it. All that being said, KubeVela is a great way to create services for developer platforms, and I encourage you to try it out if you haven't already. Thank you for watching. See you in the next one. Cheers.